Hello everyone, my name is Pandekapian Zumarsyah and I will share my research about few-shot weakly supervised segmentation for retinal fundus images using meta-learning. I'm with Professor Hanung Adinugroho and Dr. Iki Ardianto. So the main problem here is glaucoma, which is the second leading cause of blindness with around 80 million cases in 2020 alone, and glaucoma has no cure, so early diagnosis is crucial. The diagnosis itself involves the segmentation of optic disc and optic cup. However, it is complicated, slow, and costly. Deep learning enables high-performance automated segmentation. However, it requires training with many densely labeled images. There are various works on deep learning with limited labeled data, but they still have limitations. So we propose few-shot weakly supervised segmentation, which can utilize a small amount of sparsely labeled data like this to perform fundus images segmentation. Our study is unique compared to previous studies as it involves multi-class, multi-channel medical images. This is the system diagram. So it starts with sparsification, converting dense label into sparse label, and then we use the support data to train a meta-learner, and then we use the meta-learner to predict query images, and finally we evaluate the result. There are three important things here. The first one is the sparsification, next is the meta-learning algorithm, and finally how to train and tune the model. The sparsification techniques involve converting dense label like this into various types of labels. There are points, grid, regions, contour, and skeleton. So there are various sparse labels. And regarding the meta-learning, we use WeaSeL, which involve two backpropagation, and also ProtoSeg, which involve support prototypes. Regarding the training and tuning strategy, we propose combine, which is utilize all types of sparse label alternately. So one step might use points, another step might use contours, and another step might use regions, and so on. It proved to be more effective and efficient. Regarding the experiments, we use RIM1TL as the source dataset and RIS-DGS as the target dataset, and we use intersection over union as the segmentation matrix. In comparison, our new implementation is better in terms of sparse labels and also in terms of meta-training. As you can see here, in almost all cases, our new approach, the blue one, outperforms the original approach, the red one. About sparsities and shots, here we have multiple sparsity values, and on the top we have multiple number of shots. And in general, there are no major differences. However, in grid and regions, they are more consistent. And also, WeaSeL and ProtoSeg achieve similar performance except in contours here, where ProtoSeg, the blue one, is certainly better. We also compare our study with previous studies. Although previous studies use unsupervised domain adaptation with slightly different dataset, despite the less fair comparison, our approach can be better than unsupervised domain adaptation approach. So in conclusion, using meta-learning for few-shot weakly supervised segmentation, we can create an automated OD and OC segmentation model with a small amount of weakly labeled data, potentially aiding in glaucoma diagnosis. Thank you very much.